Welcome back, viewers of Juddy Productions. In today's video, we're looking at Unit 3 General Maths, Area Study 1 with data analysis. The topic is data transformations, and this is one of, I think, 6 different videos on data transformations. And today's skill will be the log y transformation. So let's jump straight into it. The log y transformation involves compressing the larger y values more than the smaller y values. In the log y transformation, the x values remain the same. So visually in both these graphs, you can see the larger y values are being compressed considerably to generate a linear relationship, and the smaller y values are only being compressed a smaller amount. So our scenario, consider the following data sample that represents the likes that a social media post has and the time in hours since posting. So here we have a table with the time in hours since posting and the likes that have been generated by a social media post. We now wish to perform the following tasks. Number 1, we want to enter this data into the TI Inspire CAS calculator list and spreadsheet. Number 2, we should perform a linear regression and record the following values. Task 3, describe the relationship between the two variables. Task 4, we want to determine the least squares regression line. Task number 5, we want to generate a scatter plot using the TI Inspire CAS calculator. Task 6 is to generate a residual plot, also using the TI Inspire CAS calculator. And finally, task 7, we wish to perform a residual analysis of this data. So let's use the TI Inspire CAS calculator to perform tasks 1 to 7. So we open a list in spreadsheets, we label the first column time and the second likes. We then go to the menu, statistics and stats calculation and use the A plus BX format. The X variable was time and the Y variable was likes. And there's our summary of data with the A, B, R squared and R value. Next, we go to graph this data. Now we plot this data. On the y-axis, we have likes, and on the x-axis, we have the variable of time. And we get this graph. Looks quite curvy. Menu, analyze, regression, linear regression, A plus BX. So there's our linear equation for the least squares regression line. We're going to menu, analyze, and residual to analyze our residual plot. And there we have it. Looks like a smiley face. Task 2 was to perform a linear regression. So here's our summary of data. The y-intercept was found to be negative 581. The gradient was found to be 250.7. The Pearson's correlation coefficient, that is the R value, was 0.820. And the coefficient of determination, being the R squared, was 0.672. Task number 3 was describe the relationship between the two variables. So we look at this visual, we see that a Pearson's correlation coefficient of 0.82 places the relationship between these two variables, or the association, in a positive and strong classification. So the strength is strong, the direction is positive. However, when we looked at our original data of our scatter plot, we see that this form appears to be nonlinear. Task number 4 was to determine the least squares regression line. We found the least squared regression line to be the likes is equal to negative 581.0 plus 250.7 times the time in hours. Remembering, of course, that no matter what the data distribution, we can always generate a least squares regression line. It doesn't guarantee that it is the proper relationship between the two variables, however. Task number 5, we should generate a scatter plot. In the blue dots are curving from the bottom left of this graph to the top right, and the line of best fit really doesn't go through many of those points at all. Task 6 was to generate a residual plot, and there's our shape. Task 7, perform a residual analysis. So this plot displays a clear pattern. The residuals are positive, then negative, and positive again, much like a smiley face. This plot does not support the assumption of a linear relationship between the variables. We always go into a residual analysis assuming the data is linear until we can look at our residual plot. Okay, so this doesn't look like a linear relationship at all. It may be possible to linearize the data by applying a transformation to one of the two variables. So we wish to repeat this activity using a log to the base 10 y transformation, which in this case will be a log to the base 10 of the likes. So our table has been changed, the time in hours stays the same, our likes has been grayed out or ghosted out, and we're going to focus on the log 10 of the likes. Okay, so we can use our calculator to calculate the log 10 of the likes values. And again, we're going to perform the same 7 tasks. So we're going to put this data into the TI Inspire CAS calculator. We're going to perform a linear regression. We're going to look at describing the relationship between the two variables. We will determine the least squares regression line for this transformed data. We will generate a scatter plot also for this transformed data, as well as a residual plot. And finally, we'll perform a residual analysis. So let's now use our TI Inspire CAS calculator to perform these tasks. We go to our list and spreadsheets. First column we're going to label as time, second was likes, and the third we're going to use was the log of the likes. Now to generate the log of the likes, we press equals, log function to the base 10, we have to state the base 10, and the variable is likes. So we type in likes, and that fills all the data points. Let's now go to menu, stats, stats calculation, a plus bx format. The x variable again will be time. The y variable this time for our transform data is the log of likes. And there's our linear regression for the new transform data with the a, b, r squared and r values. We start a new graph. On the vertical axes, we have the log of likes. On the horizontal axes, we have time. Nice and straight line. Menu, analyze. Let's do a linear regression in the form of a plus bx. And also menu, analyze, residual, and show the plot. Well, here's our residual plot as well. Task number 2 was to perform a linear regression. So here's the summary of our transform data. We find the y-intercept to be 1.0213, the gradient to be 0.2486, the Pearson's correlation coefficient, the R value to be 0.9997, extremely high, as well as the coefficient of determination, the R squared value, having a value of 0.9993, also extremely high. Task 3, let's describe the relationship between the two variables. So based on the Pearson's correlation coefficient and the graph of the scatter plot produced, we can see that an R value of 0.9997 classifies this relationship as extremely strong and positive. So the strength is strong, the direction is positive. The form is also linear based on the scatter plot we've already observed. Task number 4 was to determine the least squares regression line. So it is as follows. The log to the base 10 of the likes is equal to 1.0213 plus 0.2486 times the time in hours. Task number 5, let's generate a scatter plot. Looks very linear upon observation, and that R squared value is extremely high. Task number 6 was to generate a residual plot. Task number 7 was to perform a residual analysis. So first of all, the residual plot displays approximately equal numbers of points randomly scattered above and below the horizontal x-axis. No clear pattern is displayed, meaning there's no above the line, below the line, then above the line that you get in a smiley face pattern, and there's no below the line, above the line, below the line that you'd get in a frowny face pattern. This plot supports the assumption of a linear relationship between the variables. This is the correct transformation for this particular set of data. So let's conclude our findings. The original data has the following least squares regression line. It has the following scatter plot and the residual plot. It has a high R value of 0.820. It has an R squared value of 0.672. The original data probably have a nonlinear relationship. The residual plot does not support the assumption of linearity. So transformation of the data may be required. A least squares regression line should not be fitted to data that is not linear, as any interpretations or predictions will not be accurate. We then performed a log to the base 10 y transformation. So our new least squares regression line for this transformed data is as follows. The log to the base 10 of the likes is equal to 1.0213 plus 0.2486 times the time in hours. And that generates a very linear relationship. It also generates a residual plot that has points scattered above and below the x-axis, almost equal numbers. So this has improved our R value from an original value of 0.820 to a new value after transformation of 0.9997. It's also improved our R squared from an original value of 0.672 to a new improved value of 0.9993. So the log to the base 10 of y transformation has improved the original R and R squared values. The log to the base 10 y transformation has linearized the data. This is the correct transformation for this particular set of data. So log to the base 10 of the likes equals 1.0213 plus 0.2486 times the time in hours is the best relationship available for these two variables. You've been watching a Juddy Productions video. If you've enjoyed and indeed learned something from this video, then please remember to like, share, comment, and subscribe. And as always, thanks for watching.